Welcome to one more episode Micro Podcast Digital Transformation Industry 4.0. And I'm Vijay Gunti. I am your host today. With me is Naveen Balani. Naveen is a blockchain, AI, and IoT leader, also a Google Cloud certified fellow, author of definitive handbook series such as Enterprise IoT, Enterprise Blockchain, and Real AI. Naveen, welcome to our show. Can you please introduce yourself to the audience?
Yeah, thank you, Vijay, for having me here. Yeah, hi everyone. I'm Naveen Balani, having 20 years of experience in building enterprise products using exponential technology, specializing in cloud AI, blockchain, and IoT. I'm currently focused on building financial products using AI and blockchain. I'm also a Google certified fellow, innovator, blogger, and author of several leading books. And for more details, you can visit my website at naveenbalani.dev. So, over to you, Vijay.
Good to know, Naveen. So my next question, Naveen, is about what are the business benefits challenges you see in the adoption of digital transformation industry 4.0?
So yeah, that's a good question, Vijay. So if you look at manufacturers and industries, right? So large manufacturers have already been using some kind of automation and smart technology to streamline and optimize their processes, and in turn improve their operations and production efficiency. Now, as manufacturers start to move towards the next industrial revolution and technologies which available today that can analyze uh, massive volumes and variety and velocity of data generated by various machines and sensors, there is an opportunity to streamline this information to further improve the manufacturing process, and more importantly, developing connected products that can enhance customer satisfaction and give real-time visibility on how the plants or manufacturers or the devices are doing, and that can lead to open up new financial business models. And if you look at the recent pandemic, right, these are fueled this further and led organizations to move towards this strategy quite quickly. And and what I see is I think the whole notion of connected products, right, is the key. And the combined power of technologies like, let's say, AI, IoT, cloud, and blockchain will lead the next wave of industrial automation. And since the technology exists, uh, I mean, the challenges are definitely around end-to-end implementation and models. When I talk about models, these are basically machine learning models, predictive models, cognitive models, right? These are not readily available for consumption in various industries. For instance, you don't have a ready available model for various autonomous manufacturing use cases. Things like driverless cars, right? Models are still being built and evolved. Uh, Sensors, IoTs, devices, right? How the interaction works, what kind of signals we'll get in a connected world. All these models are being involved, and 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 challenges are definitely once you have this large amount of data, a lot of time would be spent on preparing the right data, model development, training, evaluation. Uh, so a lot of work needs to be involved to make this happen. And if you look at devices like when in a connected world, so you have like IoT devices, sensors, and by default the entire journey, right? They are not tracked, uh, like from inception and how it is being consumed. So this whole notion of blockchain, right, comes into play, and you need to track end to end product designing capability and taking it to the markets. And all of these standards, I would say, right, let's say whether it's blockchain or integration, are still evolving, and picking up the right platform or tools, right, still remains a challenge. And I would say overall an integration solution, right, is not yet available, right, and needs to be implemented. So in terms of technical challenges, yeah, we have to look at end-to-end tracking, visibility, and the right set of tools and technology that needs to be adapted by organizations.
Yeah, good to know, Naveen, and sharing your thoughts on this. So, my next question is about so what kind of use cases, case studies you have worked or working? Can you share some thoughts on that also, Naveen?
Yeah. So use cases. Let me give you a real life example. Let's take an example of. I'll take a very simple example. Right? Let's take an example of leading elevator manufacturing company, right, which supplies, let's say, elevators across the globe. And these elevators have some instrumentation built in, right? Let's You have already door sensors, a weight sensor, which gives you a buzz if it goes beyond a particular weight. Uh, but if you look at the elevator company, right, they don't have any visibility on how the elevators is used across the globe. And therefore, if you want to address, right, few questions and get those answers, like for instance, are these elevators working as expected as per the specification? Is there a failure condition? What kind of failure has occurred in the past? How are failures handled? What is the typical downtime? How effective is, let's say, after sales in that region? And is there an expertise available to handle the given failure condition? And most importantly, are the spare parts available, right? And how soon can the restoration process starts? And if you look at the way uh, this can be augmented is, right, by basically applying proper applications of various digital technologies like IoT, AI, and blockchain. And most importantly, right, what you do here is basically start capturing and analyzing the product usage, operational failure data, and then basically try to improve the customer satisfaction and services. So IoT alone will not transform the end products, but the entire manufacturing process, right from the start where the elevators are manufactured, the supply chain process, the logistics, everything needs to be streamlined, right, to enhance the operational efficiency and productivity and deliver better financial gains and customer experience. And the way you would do it, you realize is basically you do it incrementally. So you basically break down your journey, let's say, into monitoring and utilization, condition-based maintenance, predictive maintenance, optimization, and the last is basically connecting and basically creating connecting solutions. So what I call this as the connecting solutions. And if you look at monitoring, right, just take an example. So what you do here is basically you start with asset management, identifying the assets, instrumentation. How do you handle connectivity, right, to devices, right, as per po- point as per the above points, and basically identify various patterns, right? How does the device connect it to the platform? How does the instrumentation work? So everything is connected. Now when you talk about instrumentation, right, it's all about understanding, right, what kind of any new hardware components like devices, microcontrollers would be required. For instance, it has to basically start from the inception itself, like the design itself, right? Now this design, the new generation, right, elevators have new connected design, right, inbuilt as part of their framework. Like for instance, in order to maintain, let's say, optimum temperature uh, and smooth the functionality of elevators, right, taking in account the surrounding external factors, and which may be different in different region. So you basically has to break up these designs and break up these all this requirement as part of your design, right from the inception, and bring some rules around this, right? Let's say if ambient temperature goes beyond a certain value, right, then what needs to be done, what needs to be triggered. Then when it comes to monitoring, right, once you have everything connected, right, then you how do you monitor this information and make this data available to the core platform? So that's where, if you're looking at monitoring, this data, right? So that's where the whole concept of cloud as well as edge on the cloud comes in, where you are gathering all this information into uh, a cloud which is basically nearby in the vicinity, right? Which can take and consumes a vast amount of data, right? And help you to better monitor the elevators, right? And provide real-time decision making. At the same time, passes information to a central server where you can monitor, right? All your elevators across the globe. And then once you have the monitoring in place, right, then you can have basically automation in place. Which basically, so a lot of these uh, audit happens, right, on elevators, right? So the audit department comes and basically checks, right? I mean, 30 40 features, everything is working fine, expected. And all these actually in future can actually be automated, right? Where you can, somebody can do an audit of the entire elevator, right from, yeah, sitting remotely and getting all those data points, right, captured, and which is unbiased, and that can be used for regulation purpose. And then the third chapter is around the condition based maintenance, where, for instance, how do you, once you have the actual data gathered from various devices, so what kind of manufacturing activity needs to be performed on the physical assets? So these can be basically a set of continuous measurements like temperature, vibrations, air pressure, heat, etc., right, on physical assets. And how do you basically use this data in terms of your surrounding uh, environment? And then what, since you have all this data available, then you can definitely, you can have two approach. Either you create some rules which defines what kind of I mean, temperature needs to exist, right? What kind of surrounding environment needs to exist? Or you could, once you have enough data, you could provide condition based maintenance using machine learning model, because you have that much data at your disposal, right, to create models and learn from it. And once you have, the next evolution is making about the predictive maintenance, and this is the ability of the system, right, to predict a machine failure. So there's the highest level of learning that you can get, right? For instance, one is the ability to predict when the machine, right, asset can fail, and secondly is to perform maintenance activity before malfunction happens. And this basically involves, right, and this basically involves basically getting the actual wear and tear data of the parts, right, provided through the connected devices. So one can possibly predict, right, the remaining life cycle of an asset, and the when the maintenance needs to kick in. So imagine maybe a dashboard with lists of all assets and its metadata, like manufacturing date, install type, actual usage, and maintenance activity carried out during, let's say, condition-based maintenance, and then basically predicting the rest of the life cycle. And going back to the, let's say the elevator use case, right? The example of elevator lift cables, right? And can a system predict whether the cables, right? When does the cable needs to be changed? And manufacturing innovation, right, needs to happen in elevator cables, like using super light carbon fiber optics that can increase the lifespan of the cables, but still changing the lift cables is a costly maintenance activity, and the failure can cause a lot of disruption. So ensuring at the same time availability of new cables, specialized technical availability, compliance checks, and all those factors, right, can be brought together, right, if you know that system is about to malfunction, right? So that's an example of predictive maintenance. And finally, once everything is smooth, right, it's all about optimization. So optimization is basically about identifying new insights, right, based on existing data that can be further help refine the manufacturing uh, process. For instance, the outcome of, let's say, predictive maintenance can understand failure patterns better and look at corrective ways to schedule services across the globe and order spare parts effectively. In turn, optimize the supply chain process. Simple example you have seen, right? Like going back to the elevator use case, right? If the, let's say, if the elevator is fully occupied, uh, you have still seen the elevator still is fully occupied, right? It still stops at multiple floors, right, due to passengers waiting to enter, right? Only to find there is no room to enter in the elevator, right? So simple things, simple rules can be used for optimization, right? Whether you can look at whether you can look at somebody's waiting, right, through technologies like, CCTV, deep learning, and so on, and then use this data, right, to ensure that okay, the elevator stops at the required. Whether it's supposed to stop right at a particular floor or not. And this is for 20-floor building. Let's say you have 100 floors and so on. And so, definitely all those optimization needs to happen. And fifth, I would say, is the connected solution, because now you have everything connected. You can look at new business models, right, that can evolve in future. For instance, let's assume that the elevator company, right, relies on third-party vendors for their logistic and shipping of machinery and spare parts. And so getting real-time visibility into moving parts across the globe, along with external factors, can help you plan the contingency better. For instance, if it takes X amount of time, right, to get spare parts from one location to another location, using real-time weather insights, integrated systems, you could definitely plan it out, saying, okay, what is the best way, right, for me to get this part shipped, right, to the location. And yeah, so I think in a connected world, a lot of these use cases would evolve over a period of time.
Yes, yes, Navin. There can be many use cases which we can delve deeper, right? I think this 15-30 minutes will not be sufficient to talk lengthier use
Yeah.
cases. Yes. So my next question, Navin, is all about. Can you also share about the multi and hybrid cloud strategy? What are your thoughts?
Yeah. So in cloud computing, I think it's an important topic, which basically cloud computing kept the businesses and remote workforces, right, connected during this ongoing coronavirus pandemic. And as we move to 2021, like every organization, right, would eventually adapt some kind of cloud model. And existing cloud businesses, right, would look at ways to streamline their business process for better continuity. So what is an hybrid and multi-cloud platforms? Basically, it's a cloud computing environment that helps organizations to deploy and manage their applications on-prem, private cloud, or cloud on the edge, or across multi-cloud providers in a unified and consistent way. For instance, organizations and industries which are already running, let's say, factories and solutions on premises can leverage their existing infrastructure, right? And maybe modernize the applications and build regulatory and compliance solutions where data doesn't need to leave the geographical boundaries. So these organizations can actually scale their on-prem floor or infrastructure, right, to the cloud and leverage various cloud services to run maybe non-sensitive compute tasks. And if you look at when everything is connected, right, and with 5G gaining momentum, we would definitely see new class of cloud native applications, right, that would require data and compute to be located closer to end users to provide real time, ultra low latency, and immersive experience. So next generation definitely would require, let's say example of low latency streaming, gaming, and virtual experience, and the whole collective intelligence, right, that we need to deal with. And with the adoption of IoT, like every object, right, would be eventually connected, right, to give their data to provide actionable insights on its own or through other connected objects. And to realize this, cloud on the edge, right, would play a very critical role. So organization, right, needs to be agile and leverage. I think look at ways to leverage cloud computing platforms, right, to modernize their application and build basically applications that can seamlessly run anywhere. Let's say be it cloud, on-prem, multi-clouds, or on the edge. So definitely new investment needs to happen from organization, right, to move towards that move. And and there are platforms which are already available, right, which are making towards that move. Like for instance, Google Antos, right, gives a unified approach to streamline on-premises and multi-cloud environments, and it provides a unified way, right, to track your entire, track your entire workloads, right, across all these cloud models. And I would say you see definitely see a lot of developments in this space. I mean, from infrastructure modernization, integration, tooling, and scaling, right, for hybrid and multi-cloud adoption.
Fantastic, Navin, for sharing your thoughts on this. So, my next question is about can you share your thoughts on emerging technologies? You have been working on this technologies and you have written excellent books on that IoT, AI, and blockchain. How does these affect or play a role in the current Industry 4.0 era?
Yeah, that's a good question, Vijay. So, if you look at a manufacturing system, right, if it needs to be fully autonomous, right, uh, for one of the fundamental things it needs to do, it needs to understand its data, right, and its surrounding environment, and then execute decision with, let's say, less human intervention. And if you start to classify the various streams of data, right, so let's say in a manufacturing context, right, can be broadly classified into four types, where let's say you have structured data, where you have a sequence of date or time series information from sensors, right, which needs to be captured and analyzed. The unstructured data, like images from cameras used by robots for automated robotic systems for navigations, or basically robots helping for automated product classification. Uh, it can also be a combination of structured and unstructured data, like in the case of augmented reality, right, where you superimpose images and text to drive outcomes. So basically, you could use 3D virtuality, digital twins concept, right, where you can look at both of these technologies, right, where you don't need to be physically present, but at the same time monitor, right, and work with the devices. And the fourth being, let's say, behavioral and surrounding data, where devices learn from interaction and integration. And these are the cognitive aspects of all the devices. And if you look at these technologies, right, I mean, definitely when you talk about data, right, you talk about how can you look at a wide variety of data and make sense of it. And that's why technologies like machine learning and AI, right, would help us derive intelligent insights for each of the above scenarios. For instance, machine learning models can be built for analyzing the time series information from sensors, or let's say anomaly detection. I talked about the elevator use case, which we basically can harness the data for various condition and predictive based maintenance, and output can be fed to other systems to take corrective action, like let's say ordering new parts, right, before even a failure happens. uh, Technology is again advancing, where you have deep learning models, right, where you can create CNN convolution neural networks that can be used for computer vision, which can be used for robots for automating any activity involving image analysis, like product categorization, product placement, navigation, right. So you can have robots deployed on the floor plans, right, which can look at all. We can basically use image, right, as one of the inputs, and then do a lot of real-time decision making. And optimization, it's an evolving process, so it can be employed at every step of process to identify bottlenecks and improve efficiency in the industrial processes. And if I also feel there can be some tasks, right, which can't be fully automated, and that's where humans and robots needs to work together to achieve the highest level of automation. So if you sum it up, definitely technologies like IoT will be there to allow us to collect and data from pretty much every object. Cloud will allow us to effectively store, manage, and extract value from continuous streams of sensor data. And when I talk about cloud, is basically about on cloud, on prem, or on the edge. AI will allow us to derive insights from massive streams of data and make sense of data. And technologies like blockchain will provide autonomous trust and compliance and improve efficiency of the business operation. So if you basically, the combinatorial power of technologies like AI, IoT, cloud, and blockchain, right, will lead to the next wave of industrial automation.
Yeah, fantastic, Naveen, in sharing your thoughts on the digital emerging technologies. So, my next question is about the career opportunities. I know we keep hearing a lot of technologies, a new business norm, and there is a lot of uncertainty to the minds of these fresher students and professionals. Where do we go? So, according to you, what kind of career opportunities you see at least in the next 2 to 5 years, and what do you recommend, Naveen?
Sure. Uh, so, in my view, the next generation of products and technology, right, would help in realizing the true value of data for any organizations and industries and derive actionable and real-time insights. So it would be an arena of integration where every uh, technology, right, would be connected to provide the data or to derive actionable insights on its own through other connected objects. So skills around integration, end-to-end integration, having end-to-end visibility, right, uh, would be definitely required. So there'll be new class of applications which require real-time decision making and low latency requirements, where that needs to be deployed on the edge to provide immersive experience and provide real life experience from the comfort of the home. For instance, if you look at this COVID scenario, right? We should. I mean, let's say you're doing a virtual uh, mall shopping, right? Technology will exist, which will basically provide real life experience, right? So you don't need to go out of your comfort room. You can actually visit any mall, right, and try and buy stuffs, right, which provide real life experience in future. Education is one area which will definitely be transformed with augmented reality. We already have virtual classes going on, but what is the next step of uh, I mean, a breakthrough that can happen in education? And I feel education, the whole notion of virtual online classes, virtual, will take further. We'll have more augmented reality, right, in terms of learning, books, all of the things, right? I think there's a massive disruption that can happen in the education space. So technologies that can enable those, right, from augmented reality, VR, will definitely we can look at in the next 2 to 5 years down the line. Quantum computing is one which would advance and would be mainstream and help us deploy new class of AI and machine learning models to solve variety of use cases and for medical science advancements. A lot of quantum physics, good knowledge of maths, right, would be required, right, to build and those kind of new models. I talked about hybrid and multi-cloud strategy. I think that would be probably the norm, and you would basically build applications that can be deployed anywhere. So whole things around skills around cloud natives, developing cloud native applications, right, will definitely be the norm. So everybody would be talking about that, and that will be the new norm for deploying any applications. These specialized skills like, let's say, trust and compliance, security, regulatory, data governance, AI and trust model, right, would have a separate focus. And technology similar to blockchain, right, would be mainstream and provide a trust in a connected world. At the same time, also feel a lot of these organizations, right, will use technologies and be brand ambassadors for solving various social and economical problems and have dedicated business units which will make an impact. So I'd say future looks very interesting and connected, and I think ample opportunities will exist for everyone, and overall making a world a better place to live in.
Thanks, Naveen, for sharing your valuable insights and suggestions and final experiences on digital transformation, Industry 4.0, and emerging technologies, on the business benefits, challenges, and opportunities, and also sharing excellent use cases which you have been working on, and finally sharing your advices to students, freshers, and professionals. Thank you for joining us.
Yeah, thank you, Vijay, for inviting me to the postcard, and thank you all audience for listening in.
Thank you.